Hello class, welcome to this chapter 3 review video. So we're going to go over the review problems from Canvas. So let's go ahead and get started. So chapter 3, like I said, is all about transformations. So quadrilateral D prime, E prime, F prime, G prime is the image of D, E, F, G after the following transformation. So we have a rotation 90 degrees clockwise, which is indicated by the negative sign here, but the origin. So now we want to transform each of the vertices, each of the corner points of this quadrilateral. So first, you got to know the rule for rotation, or about 90 degrees clockwise about the origin. So you got to know that rule. So let's go ahead and list out that rule. So the rule for that is if you're transforming XY, it's going to turn into, so if you're doing 90 degrees clockwise, that's the same thing as 270 degrees. Sometimes in a problem they might write it this way, so you might want to know both ways. So this is the same thing as 270 degrees counterclockwise, or which is positive, so I'll just write it as positive about the origin. So they mean the same thing. And so it's going to be y negative x. Okay, so that's the rule for that. So now we're going to do that for each of these points. So the f, coordinates of f, and I'll write it off to the side here, are positive 1, positive 1. And so when we transform that, so here they're gonna swap, right? X and y swap, and then the second number changes in sign. So we have 1, 1. When you switch them, it's the same thing. And then the second number changes sign. Okay, so that's f prime. And then let's do E, because we forgot to do E. And let's do it in order. So we have D, E, F, G. So D, negative 1, negative 2, so negative 3, negative 1. Going to this coordinate right here. And that transforms to D prime, which is, and D prime. So we're going to switch these. And then the second number has to switch sign. That's what that negative indicates. That negative indicates that you switch the sign. So right now it's a negative 3, so it's going to turn into a positive 3. Now E is negative 3, positive 3. So again, we do the switch. And then change the sign of that second number. So negative 3 turns into positive 3. And then now we have G, finally, negative 1, negative 3. And that transforms to G prime, which is you switch the numbers and change the sign of the second number. So negative 3, positive 1. All right, so these are my coordinates, and you're just going to write them here in that order. All right, and that's how you would type them into the boxes. All right, so next problem, triangle T prime U prime V prime is the image of triangle TUV after the following transformation has occurred. So you got this transformation, and you have to know that this is a translation, okay? So this right here is a translation. Why? Because you're adding or subtracting a number to X and Y. And so this means that you're shifting it to the right, and this means that you're shifting it down. Okay, so you're going right 3, down 5. And so you can transform the coordinates directly by adding to the X and Y, or you can move the coordinates, actually physically move this. So I'm going to show you how to do both ways, just so that you know how to do both ways. So let's go ahead and transform using the coordinates first, and then we'll show you physically. So we have U, let's see. Let's start with T, TUV. So T, negative 1, negative, so it's a negative 4 and 0. And then we're going to transform that using that rule. So it becomes T prime. And so basically you're going to do negative 4 plus 3, and we'll do it down here so we can show you the work. So we got T prime, negative 4 plus 3, and then 0 minus 5. So again, we're using those two numbers, the underlined here, a double underline there. And so negative 4 plus 3 is negative 1, and then 0 minus 5 is negative 5. All right, so that's how you would use the transformation right away. The other way would be to physically move the points. So let me show you that as well. So u is negative 5, positive 5. And so if we physically move it, we have 1, 2, 3. That's plus 3. And then you have minus 5. So 1, 2, 3, 4, 5. And so u prime would be located there. And so that's negative 2, 0. Okay, so you could do either one of those ways. I'm going to go ahead and continue with the coordinate transformation as opposed to physically moving it. But that's an option for you if you want to do that as well. So for v, you have negative 3, positive 4. Go ahead and add the coordinates. So negative 3 plus 3, and then 4 minus 5. It's going to be 0, negative 1. Notice how I'm showing my work here so you can see exactly my steps. All right, this is what I want you to do. I want you to show your work so that I know how you got that number. Okay, here we got 0, negative 1, and then those are my coordinates. So negative 1, negative 5. 0, negative 1. All right. So the next one, we have a quadrilateral, and the transformation is a reflection across the y-axis. So let's recall where that rule is. So that rule is when you reflect across the y equals negative x rather. So this is a reflection across y equals negative x. When you do this, the x, you switch the x and the y, and because it's negative x, these are both going to be negative. Okay. So that's the rule for reflection across y equals negative x. So we're going to do that for each of these coordinates. Now, let's see here. So we got b, coordinates of b are negative 1, 2, and that's going to transform to b prime, which b prime, so now if you use the rule here, you switch x and y, so this is going to be switched here. But then the negatives here indicate that you switch the signs. So this is going to be negative, this is going to be positive. And so that's going to be positive 1. All right, so then C is negative 2, positive 3. And then so if you transform that, you're going to have 3, negative 2, then switch the signs. So negative 3, positive 2. We have D here, which is negative 4, positive 3. So switch the numbers, change the signs. So that here it's going to be positive 4, negative 3. And then lastly, we have E, which is negative 5, 0. Switch them, change the signs. Now this is a 0, so it doesn't really matter if it's positive or negative. 0 is neither positive nor negative, right? So we're just going to leave it at, you can write a minus there, but that doesn't mean anything. It's just 0. And so we have 0 and then positive 5. All right, so those are my coordinates, and then we can go ahead and you can just go ahead and fill in the blanks here with those coordinates, okay? All right, so quadrilateral. So we got another quadrilateral. Looks like some kind of parallelogram. Is the image of EFGH after the following transformation. So we got a reflection across y equals negative 3. So remember, when you see a reflection across, so when you see y equals negative 3, that's a horizontal line. So that's a line that goes like this, okay? When you see x equals a number, that's a vertical line. So y equals a number, horizontal. X equals a number, vertical. So this is going through y equals negative 3. So y equals negative 3 is 1, 2. This is negative 3 right here. And so you're going to have a line, and I'll try to draw this, that cuts through negative 3 like that. So it's horizontal. So this is my y equals -3 line of reflection. So we're going to reflect about that. So you have to visualize this. So the distance here from E to F is 2. And so it's going to be 2 on the other side as well. Okay, so we're going to have to move 2 units. So it's going to be 1, 2 over here. So if it's 2 units here, up. If it's 2 units up here, I'll give it a second here. So if it's 2 units up here, then that means it has to be 2 units down there. Okay, so this is going to be F prime. And E prime, E is still going to stay there because E is right on the line. So if you're right on the line, you're going to stay on the line. And then H, looks like H is going to switch with G. H is going to go on the other side. So H prime, and let me use another color here. So now H prime basically switches spaces with G because G is above, and so G is now going to be below. All right, and so that's what's going to happen here. And we have our, so we have this guy right here. All right, so then we end up having something that kind of looks like this. And so that will be a reflection about y equals -3. So now we can go ahead and write down the coordinates. So E looks like it stays the same spot. So E is at -4, -3. And then F prime rather, is at -4, -5 according to the coordinates here. G prime is at 0, -4. And H prime is at 0, -2. So we got our coordinates for the transformation. All right, so let's look at the next one. So here now we're doing a reflection across x equals 2. And so there's no, I mean, you could figure out a rule for this, but of course it's just better to visualize it and then change it accordingly. So let's go ahead and do a reflection across x equals 2. So we know since this x equals a number, it's going to be a vertical line. So it's going to be like something like this. And so we have 2 over here, and it's going to be a vertical line that cuts through it. Okay, and so this is the line x equals 2. And so now we want to reflect about that. So we know that J is 2 units across from x equals 2. And so it's going to be 2 units across on the other side. So that's over here. It's going to be my J prime. Right off the bat, we know what J prime is. And then L is 3 units across. So it's going to be 3 units across on the other side. So it's going to be over here, L prime. Then we have K is 2 units across, so it's going to be 2 units across on the other side. And right off the bat, we're able to transform this. It doesn't take very long. And it looks something like that. So you can see it's a nice little mirror reflection. So now we can write the coordinates down. So J prime is 1, 2, 3, 4, and then -4. So 4, -4. K prime is actually right here. K prime is 0, -1. So it's on the y-axis. And then L prime is -1, -4. All right, and those are my coordinates here. So now let's look at the next one. This time you want to write the rule for the transformation from the unprimed to the primed triangle. So write the rule for this transformation. So first off, you can kind of tell that it looks like a mirror reflection about something. So it looks like a mirror reflection about a line that looks kind of like this. And indeed it is. So if you look at that, if you were to slice that in half, right? it's going to look exactly like that, a mirror image. And so let me kind of be hard to convince you, but me, I won't be able to rotate this, unfortunately, but it's a mirror image about that. So because it's like if this is your center, then this is, let's say that's 1 unit across. It's not, but let's just say it is. Then this is also the same distance on the other side. And then if you look at E, this is the same distance as this, and so on. And so you can tell that it's a mirror image if you think about it that way. And so because they're a mirror image, this line is actually y equals negative x. Okay, so this is one of your special rotations, or reflections rather. So this is a reflection about y equals negative x. Means the rule, remember that the rule for that is that you basically switch the x and the y, and then you change the sign. So that's your rule for y equals negative x, and that's all you need to do. And we can verify this. So if E is -2, -2, well then if we switch them and then change signs, that's going to be +2, +2, right? Which is what we have here. So this checks out. And then if you were to do it for C, C is -5, -4. And then if you switch it, you get -4, -5. But then you change the signs because there's negative signs there. So you change the signs. It's going to be +4, +5. So +4, +5. That is true. It works out here. So this is definitely a reflection across y equals negative x. And so the rule is -y, -x. All right, so write the rule for the transformation from the unprimed to the primed. This should, there's a typo there. Should be it should be Q prime, R prime, S prime. All right. So what's the rule for that? So first, notice that the S went down here, the R went up, and the Q went over there. And so it looks like they rotated, right? It looks like there's some kind of rotation that happened where Q rotated there, R rotated up, and then S rotated off to the side. So this looks kind of like a rotation. It's definitely not a translation where it slides over, because there's no way to slide this over so that S lines up with S here and Q also lines up down there, right? There's no way to do that, unless you rotate it first, right? So you rotate it first and then you see if you can move it. So let's see here. Let's try a rotation. And this looks like, maybe a 90-degree rotation of some sort, right? So looking at this, it might be some kind of 90-degree rotation. But, we'll figure it out. So if it's not 90-degree rotation, then you do a little bit more. But it's only going to be those special rotations that we discussed, okay? So it's not going to be any weird, other rotation. You only have the 3 special ones. So 90, 180, and 270. So it looks like a 90-degree rotation. Let's try that. So we were to do a 90-degree rotation. In this case, it's clockwise, right? This is going clockwise. So that's going to be -90 degrees. And we know that doing it clockwise is the same thing as doing it 90 degrees clockwise is the same thing as doing 270 degrees counterclockwise about the origin. Okay, so they mean the same thing. So you can use either one of those rules. And so let's recall what the rule for that is. The rule for that is switch to y and the x, and then the second coordinate is negative. So basically the original x becomes negative, which is now the second coordinate. So use that rule for the problem. So let's look at and keep in mind this is going clockwise for the primed. So I'm going the wrong way. So you're supposed to go from 1 to 2. You're supposed to go from the unprimed to the primed, right? That's what it's saying here. And so therefore I'm going the wrong way. I'm supposed to be going from here. I'm supposed to be going from here to here, the other way around. right? And then I'm supposed to be going upward like that, and then the R, I'm sorry, wrong way. Okay, so I'm supposed to be going, basically rotating this downward like this, like that, and then the R like this, and then the S like this. So basically they're all going counterclockwise. So I messed up the direction. I apologize, because we're going from this one to this one, and I went backwards before. So this is actually going counterclockwise, right? If that's counterclockwise. So it's going to be 90 degrees positive. And then which is the same thing as negative 270 degrees the other way. Okay, so just switch your signs. All right, so the rule for this is now no longer negative x. It's actually negative y, positive x. Okay, so you switch the signs. You're going the opposite way. All right, so that's our rule. And so we're going to take s. S is 2, 1. It's going to transform according to that rule. The x and the y switch. And then the first coordinate is opposite sign, so it's going to be negative 1, 2. And if you think about it, look, this is actually negative 1, 2. So this actually lines up perfectly with what we want. And then we have q, so that's s prime. Let's do q. So q is negative 3, positive 1. Is 1, negative 3, so you switch them and then change the sign of the first one. So negative 1, negative 3, which lines up with that perfectly. And then r is negative 5, 0. Switch them. Change the sign of the first number, but that's a 0, so it doesn't really do anything. So I'm going to erase it. So 0, negative 5. I'm looking at the wrong one. So the R here is, look at the R in the image, not the pre-image. The R over here is 0, 5. Then I got to switch that. Okay, so I got to switch that, and then that'll be 5, 0, and then change the sign of the first number, so negative 5, 0, which lines up with this guy. All right, so this is definitely the transformation, and so we're going to say that the rule is negative yx. All right, so now next one. So we have a triangle here, and we have the following sequence composition of transformations. So we have two things going on. Remember, when you're doing this composition, it's right to left. So you do the rotation first, which is what it says here, and then you do the translation second. Okay, so which is, this guy. So we're going to rotate this first. So remember that the rule for rotation, that down here, I think we just did this recently, or we were about to. So 270 degrees counterclockwise is y negative x. And then the rule for the translation, this is saying that you're going 3 to the left. So you have to know that. The minus means you're going left. Positive means you're going right. And then positive for y means you're going up. Negative for y means you're going down. So here this is negative for x. We're subtracting. Okay, so we're going to do this rule, and then we're going to go 3 left. So let's go ahead and do that for v first, and then w and x. So v is negative 1, positive 1. And so we're going to do these two transformations back to back. Let's do the first one. The first one's going to be a rotation. So we're going to switch x and y like this. And then the second number switches sign. So this is going to be positive 1. Next, we translate it. So 3 to the left. So basically, I'm subtracting 3 from the x coordinate here, right here. This coordinate. This is my new x coordinate. So I'm going to subtract 3 from the x coordinate. And then I'm not going to do anything to the y coordinate. So it's going to be negative 2, 1. So this is going to be my new coordinate. This is going to be v prime. All right, so that's what they want, v prime. Okay, so now next one, w. is 2, 5. So let's do the first transformation, the rotation. You switch them, change the sign to that second number. So it's going to be 5, -2. And then you're going to do the translation, which will yield w prime. So you're going to do the x coordinate -3 and do nothing to the y. So it's going to be 2, -2. All right, so we got our answers there for those two coordinates, and then we got x finally. We got 3, 2. First transformation, rotation, switch, change the sign of the second number. Then you have finally x prime, and then you're going to subtract at 3 from the x coordinate, like we usually do. Get -1, -3. So these are your new coordinates for the transformation. So you'll just write them in the blanks here. All right, so the next one, got another triangle. Got two different transformations. Remember, right to left. So flexion about the x-axis, which that's what it says here, and then a rotation 90 degrees counterclockwise about the origin, which that says there. Okay, so we're going to reflect about x-axis. So we're reflecting about this guy right here. And so if I want to do that, let's go ahead and show you the rule for that. So the rule for reflecting about the x-axis is that the y changes coordinate. So basically the y coordinate changes to the opposite value. So if right here k is 0, 4, then when you reflect it about here, this is 4 away, so it has to be 4 away down here, and so it changes to -4, right? So the y coordinate changes. All right, so that's the first transformation, and then the second transformation, we reflect across we rotate 90 degrees counterclockwise. So let's remind ourselves what that looks like. Positive 90 about the origin, and so you basically 90 degrees counterclockwise, they switch, then the sign is opposite there. Okay. So we got the transformations, and we know that this one goes first, this one goes second, right? So go ahead and transform k first. K was 0, 4. So then if you perform the first transformation here, then you know that you're going to basically make the y negative. So 0, -4. That's what we did right here. And then the second step, you're going to switch the coordinates here. I'm going to switch these and then change the first coordinate to negative once you do the switch. So you switch first and then you change the sign. So this is going to be -4, 0. I switched it, then change the sign of that first one. So it's going to be +4 and 0. Okay, that's what that's telling you. Okay, so that's +4, 0. That's my Ka prime. Now let's do L prime, or L, yeah. So L is -5, +5. So then we transform that, the first, we reflect it, which means that the y coordinate changes sign, +5 to -5. And then finally we get L prime, which means we gotta switch these, which is gonna be the same thing if I switch them. And then we change the sign of the first number. So now it's gonna be +5 instead of -5. That's L prime. And then M, -5, +2. So the first thing, we change the sign of the y, just like that. That takes care of the first transformation. Finally, we end with M prime, so we switch the coordinates and then change the sign of the first number. Is +2. +2, -5. All right, and then those are your coordinates. You can go ahead and type those in here to the boxes. All right, describe the sequence of composition of transformations from the pre-image to the image. All right, so we want to go from here to here. All right, so basically they give us options here, and we got to figure out which option works best. Now, just looking at this, it looks like, so this is what it looks like. It looks like if I take V and it looks like V rotated that way. It also looks like Y rotated that way. So if you imagine this rotating from left to right in that direction, clockwise, it looks like, see, W prime rotates that way, X prime rotates that way, and then that will end up getting that shape where it looks like this, right? Where this is W, this is X, and so on. So it looks like it rotated. And so we're going to say that it's a rotation. Looks like 90 degrees. We went from here to the L position. So it looks like 90 degrees right here, clockwise. Okay, so it looks like we have a rotation -90, because -90 is clockwise. Negative is clockwise, which is the same thing as 270 counterclockwise. You can also think of it as 270 going the other way. And it's positive 270. And then the rule for that, you recall, is you switch the coordinates and then the x is negative. All right, so that's our rule. Let's see if that rule actually works first off. So W, the coordinates of W, write them down over here. W is 2, 2. And so if we do the rotation, let's say we're doing the rotation here, then you're going to switch the coordinates, right? It's still going to be 2, 2. And then the second coordinate is going to be negative. So it's going to be 2, -2. Let's go and write down what this looks like. So W is 2, -2. And so that'll be W prime. So we should call that W prime. And we'll see if that works. Then X is 4, 2. And when we do the rotation, we switch them and then change the sign of that second number. So 2, -4. Let's see. It's not going to be 4, 2, is it? Yeah. Okay. So 1, 2. This X is 3, 2, not 4, 2. I apologize for that. So this is going to be -3. So it's going to be over here. So this is going to be X prime. All right. And then, so it looks like it did rotate right down there. And let's do that for V. Let's do it for V. So V is currently where X prime is at. So V is at 2, -3. That's going to transform to, so you switch these and then change the sign of that second number. So it's going to be +2, -2. So that's V prime -3, -2. And finally, we have Y. Y is at 3, -4, or 1, 2, 3, -3. I'm counting this incorrectly. Y prime, you're going to switch them and then change the sign of the second number. Second number was 3, right? And then that changes to -3. All right, so -3, -3. And so it looks really good. It looks like if I rotated it, it'll get me to this position, which is what I want. These are all lined up now. V prime is lined up, right? Y prime is lined up. So this is perfect. This is what we want. And so now we can translate it. We can move it over to the left 2, and then move it over up 2. So to the left 2, up 2. And we could do that for all of these. Left 2, up 2, left 2, up 2, and so on. And that works for all of these. So it looks like we need a rotation 90 degrees, we said clockwise, right? We said 90 degrees clockwise. So it looks like this one, and followed by a translation 2 to the left, 2 up. So this looks like the coordinate of the sequence of transformations that we want. All right, so let's look at the next one. We have another sequence problem. So we got to figure out, we want to go from 1 to here. Let's figure out what's going on here. It looks like, if you look at the L the L went down here, right? So the L went down. The K, looks like the L flipped. So the L flipped down. The K flipped up, right? That's what it looks like because K is now on top and then L is on the bottom. So it looks like they flipped. It looks like it's some kind of reflection. And then if you notice, N is down here and it flipped up, right? To this position, and then M flipped down. So it definitely looks like some kind of reflection going on. And so let's go ahead and see if we can reflect it about something. So let's try. Well, it's gonna definitely, if it flips, it's definitely gonna be across the x-axis, right? It can't be across the y-axis because if it's the y-axis, then this is gonna flip that way, right? And we don't want L to be on the right side. L is on the bottom, right? So it can't be flipping across y-axis. It has to be flipping across x so that it'll flip on the other side down, right? And then K would flip down as well, but it would be on top, which is what we want, right? So it has to be the x-axis here. So let's go ahead and show you that. So this is the x-axis. And so L is 1, 2, 3, 4 away. So it has to be 1, 2, 3, 4 away. Down here, that's L prime. M is 1 away, so it has to be 1 away here. It's not going to be K prime, but you know, it's fine. We'll call it K prime, even though it's not really K prime. And then we have 1, 2, 3, 1. Or this is 2 units, I'm sorry. 2 units, 1, 2, and then 1, 2. And so this is going to be M prime. All right, so we got our guys. And then now, if you notice, oh, and then we need N prime. So we got, that's 3 away. 1, 2, 3. 1, 2, 3. Let's see here. Where did I get? Oh, that's not the right one. That's the second one. I want to do where's N? Where's N? Oh, N is over here. 1, 2, 3. 1, 2, 3. So this is N, then the N prime. Okay, so then notice we have, let's go ahead and draw the shape here. I'm going to erase this so that it's not so confusing here. Okay, so notice we have the reflection. So it looks like a reflection across y equals, or across the x-axis. And then if I were to take this and now move it, right? If I were to move it 1, 2, 3 to the right, that gets me to where I need to line them up. And so this is a glide reflection. I flipped it and then I glided it. So this is known as a glide reflection. But it's a sequence of transformations, reflection followed by a translation. So we're looking for a not a rotation, not a reflection across y equals x. We want a reflection across the x-axis followed by a translation 3 to the right. And that is exactly what we want. All right, so now we're going to finish off with symmetry. So how many lines of symmetry does the parallelogram have? All right, so a line of symmetry, remember, so if you have a shape, like a given shape, like a square or something, if I were to, line symmetry refers to if you were to fold it across a line of reflection, will it match up on the other side, basically? So if I were to take this square and I folded it across this line or reflected it, it's going to match up on the other side. Okay, so this is a line of symmetry for this particular square. And then similarly, if I reflected it and if I folded it across this line, it should match up on the other side, right? Now, if you were to do this for like a rectangle or something like that, then this is not a line of symmetry. Because if I were to fold it, it would actually fold like this, right? It would fold on that side, and it would not match up. So a rectangle does not have a line of symmetry that's diagonal, unfortunately. So, but a square does. If we were to do it, it would work out. But not for this guy. So that's an example of a line of symmetry. So if we fold it, it would go on the other side. So now, if I were to do a line here, and I were to fold that, well, that's not going to fold the correct way, right? So if I were to fold it, it would fold. You can verify this yourself, because this is a parallelogram. So it will not fold the correct way. So like it would probably fold like this, right? Here to do it. So it would not line up with the way you want it to line up. And you can convince yourself of this. And if you're to do this, you're to fold it that way, it's also not going to line up. It's going to line up in an odd way, and it's kind of hard to show you this. And so I would highly suggest maybe making a parallelogram like this and showing that, hey, if you're to fold this is not going to work. So it turns out that this parallelogram does not have any lines of symmetry for that reason. Okay, so similarly to the rectangle, right, where we had the rectangle is considered a parallelogram. If I were to reflect it across, a diagonal line, or like this or something like that, it's not going to work out. It's just not going to work out. So notice that this is a parallelogram. So like this side is equal to this side, but it may not be equal to this side, right? So if these are equal to each other on the opposite side, but they're not equal to the ones on the others for the other sides. So keep that in mind. That's what we're referring to here for this parallelogram. So it does not have any lines of symmetry. So no line symmetry. Whereas this regular pentagon, if you were to cut it this way, does have a line of symmetry. If you were to fold it, it would fold exactly up on the other side. Okay, so it does work out that way. It does fold up on the other side. And then if I were to do it, this is not very good, so I'm going to try to do it a bit better. If I were to do it this way, it would also fold up nicely. So if I were to fold this, it would fold up on there on that side. Okay, so it's a nice little reflection on that side. And then similarly, if I were to do this here and fold this up on the other side, it would line up to this guy. So you definitely try folding it, and then you'll see that it actually works. If you were to make this shape and fold it, it would actually work out. And then this, if I were to cut this in half and fold it, it'll fold up to this on the other side. And then the last one looks like we have this one on that side. And so it looks like we have 1, 2, 3. So we have 1 line, 2 lines, 3 lines, 4, and 5. We have a total of 5 lines of reflection. 5 full lines, right? So we have 1, 2, 3, 4, and 5. Total of 5 lines of symmetry going on for this regular pentagon. All right, so which one of the following has point symmetry about the origin? So point symmetry is basically where you have a given point, right, in the middle. Point is usually in the middle of a figure, the central point. And let's see if I can just draw something here. Okay, so I'm purposefully making this pattern different. So point symmetry is when you have a given central point, which in this case is indicated by this dot. And if I'm going one way, and this is a certain distance across, then the image is on the other side. So it's literally on the opposite side. Okay, so if this is going this way, it's going to be on the opposite side, and it's going to be the same distance. And so this tip of the square is going to be now over here. And so I'm going to have something that looks like that. And so this filled in square is going to be on this side, just like that. It's going to be closest on the right side. And then if I were to take that central point and then go a certain distance here, it would be the exact opposite side, like that, and the same distance. And so the other square is going to end up right here, right? and that's going to be the polka dot one. And then I repeat this process, right? So this little corner is this far away, and so it's going to be the exact opposite side, same length, and so it's going to be over here. And so we have a square like that, and that's going to be the blank square. And then finally, we have this one right there. That far across is going to be the exact opposite side, same length, and it's going to end up there. And so you can see that it's the same distance, right, from a central point, but in the opposite direction. And this is the striped one. And so this is what we call point symmetry, right? So in this case, this looking at this looks very similar to this triangle example. So if you look at this, this one right here, this is this distance across, and it has to be the same on the other side. So let me draw this better. Okay, so there's that. And then if I were to do it, I should have purple on that side, but I do not. I have red on that side. So this is not what we're looking for. Here, that's my central point. I extend it across here. It has to be the exact same on the complete opposite direction, which it is here, so that looks good. Let's check the other ones though. So red, red, that looks good. And then yellow, yellow, and then finally blue, blue. So that makes sense. So this actually checks out, and this is what we mean by point symmetry. All right, what is the order and angle of rotational symmetry for the figure below, if it even does have rotational symmetry? So a rotational symmetry is you take something and you rotate it, and it matches up with another part of the image. Okay, so for example, let's say I had something that looks kind of, let's say I have this shape right here, and let's do this in another color. Let's do it in blue. So I had something like that, a flower petal of some sort. If I were to take that flower petal and rotate it, right, then I would have something that looks like this, right? So it looks like an infinity sign, right? You guys know how the infinity sign looks like. It looks like this, right? So it kind of looks like that. And so this has rotational symmetry. If I had to take this and rotate it, I would get that, right? This has rotational symmetry. It also has, line symmetry. If you were to think about it, cut this. It's a reflection about this line. There's sometimes there's more than one symmetry per figure. But here, definitely rotational symmetry, and this is order 2. Okay, order 2 means that you have two things. You have two copies basically, and you get those two copies by taking one and rotating it to get the other. All right, so in this case, the angle of rotation is 180 degrees. I have to rotate this 180 to get from one to the other. Okay, so now if I were to take the same thing and I were to do this one, and then maybe this one, and then like this one, something like that, right? Well, then I got something that looks like a little flower, right? And so this has rotational symmetry. This is order 4, right? And what I did is I took this flower petal and I rotated it 90 degrees. That's how I got that. And then I rotated it 90 degrees again to get that. 90 degrees again, 90 degrees. And so the angle of rotation is 90 degrees here. And you could easily find that because you know the order. So you can say, well, full circle is 360. Divide that by 4 and I get 90. So I know I have to rotate this 90 degrees. That's one way to think about it. Okay, so here, this looks kind of similar. It does look like it has, if you were to rotate this, you would get the other guy. And so definitely, I would say there's rotational symmetry going on here. You take this and you rotate it, you're going to get this, and so on, right? Kind of looks like a fan, right? It has rotational symmetry, like a fan. You rotate it, and it's the same. So the order here is 4. And the angle of rotation, we're going to have to find that. So the angle of rotation is, well, let's see, let's find out. So if I were to take this point right here, and I rotated it to the same exact point, the tip of the fan blade, I guess you can call it, to the tip of that fan blade, well, that's a full 90-degree rotation. Notice that's a right angle. All right. You can also, if you were to break this up like this, like an X and a Y axis, it looks like an XY plane, right? Kind of like that. But you know, there's 4 blades, and since they're the same distance on each side, since they're the same spacing. If they weren't spaced the same way, this is not going to be rotationally symmetric, right? So I just take 360 divided by 4 blades, and that's going to be 90 degrees apart. But again, this falls apart if I had something like this. So I had this, and then let's say this is spaced 90 degrees, right? But then this one's spaced close together. And then it's like that. So in that case, this is not rotationally symmetric, right? If I were to rotate this 90 degrees and then rotate this 90 degrees, it's no longer going to line up with that bottom one, right? So this is the troublesome point. And so, you know, obviously they have to be the same distance across for, you know, for this to be rotationally symmetric. And so the angle rotation here is 90 degrees. If there were 5 blades and they were equally spaced apart, then you would do 360 divided by 5. So it depends on the order. So 360 divided by the order, and that generally tells you how far apart they're spaced. All right, guys, that is going to do it for the video. I hope you learned a few things from this video, and as usual, I'll see you in the next one.